So this is National 4, National 5 Chemistry. We are in Unit 1 and our topic is calculations and formula. And the subject for this lesson is going to be working out formula mass, so gram formula mass and atomic mass. And we're also going to look at percentage composition as a revision task. So our aim is to calculate the formula mass of different chemicals. In terms of success criteria, we want you to be able to work out how many of each type of atom there is in a chemical formula, calculate the formula mass of a chemical from its formula, and calculate the formula of a chemical with brackets in its formula. And also be able to state the difference between a relative formula mass and a gram formula mass. So relative formula mass, sometimes shortened to RFM or sometimes just called the formula mass, and that tells us how much one unit or one quantity of a chemical weighs. In order to calculate it, you need to have the chemical formula for the chemical, and you also need the data booklet, specifically page 7 of the data booklet. So often the case will be that you will be given a chemical formula or asked to determine the chemical formula and then asked to work out the relative formula mass. Now, to calculate the relative formula mass, there are 5 steps. The first one is to work out which elements are in the formula, then to work out how many of each element there are. Then you need to look up the relative atomic mass of each element, and that's page 7 of the data booklet. Multiply each element by the mass of atoms, and then add everything together. That might sound complicated and written in words, but when you see it done out in steps, you'll see that it's a lot easier to do than it sounds. So we'll start with our usual example, sodium chloride, NaCl. So the first step is, what are the elements? Well, in the formula, every time you see a capital letter, that is the start of a new element in the formula. So we've got Na, which is sodium, and Cl, which is chlorine. Then what we need to do is look at the number of atoms. And to do that, we look at any numbers written in the bottom right-hand side beside a chemical symbol. And sodium has nothing and chlorine has nothing. And remember, if there's nothing written, no number written beside an atomic symbol, that means that there's one of that atom in the formula. So sodium is 1, chlorine is 1. Next step, what is the mass of those elements? And this is the relative atomic mass, and you look these numbers up on page 7 of the data booklet. For sodium, the mass is 23. For chlorine, the mass is 35.5. Next step is to multiply. So you're multiplying the number of atoms by the mass in each one, and you treat each element separately. So for sodium, there's one atom multiplied by 23, which gives us 23. For chlorine, it's one atom multiplied by 35.5, which gives us 35.5. And our final step is to add the numbers together, and that gives us 58.5. So we work out our elements, then the number of atoms of each element, we look up the mass of each element, then we do multiplication and addition. So we've got another example here. We have got aluminium oxide. So we've got 2 elements, aluminium and oxygen. This time there are 2 atoms of aluminium and 3 atoms of oxygen. Now we need to look up the mass of them. So aluminium has a relative atomic mass of 27 and oxygen has a relative atomic mass of 16. Fourth step, multiply. 2 multiplied by 27 gives us 54 for aluminium. 3 multiplied by 16 gives us 48 for oxygen. And when we add them together, we get 102. Another example, calcium carbonate. Well, this time we've got 3 elements. We've got Ca, we've got C, and we've got O. There is 1 calcium, there is 1 carbon, and there are 3 oxygens. The masses are 40, 12 and 16 from page 7 of the data booklet, and when we multiply, well, 1 times 40 is 40, 1 times 12 is 12, and 3 times 16 is 48. When we add those together, we get 100. Now there is a different way of setting this out, which takes a bit less space, and is a method I would only use if I was very confident doing this. And that is you draw an arrow from the element, and then you say, for chlorine, so we've taken an arrow down from chlorine and across, and there's 2 chlorine atoms. The mass of each one is 35.5, and that gives us 71. Then take an arrow down and across for calcium. There's 1 of those. The mass is 40. When we do the multiplication, we get 40, and then we add those numbers together to get 111. So that's an alternative way of setting it out. It's up to you which one of those methods you would like. If you are doing this in class, doing this for homework, we would expect you to show you're working out and not just give an answer, because these questions are worth more than 1 mark. And so what we can say is the mass of 1 mole of calcium chloride is 111 grams. Now, sometimes chemicals have brackets in their formula, and what a bracket means is that the number after the bracket multiplies everything inside the bracket only. Now, this can be confusing, and so I've come up with a way that can help you deal with brackets without needing to worry about what do you need to multiply, what do you not need to multiply. So I've got an example here. I've got aluminium hydroxide. Now what I'm going to do is split the compound in 2. I'm going to take the aluminium, the thing that's not in a bracket, to the left-hand side, and I'm going to take the OH, which is inside a bracket, to the right-hand side. Now, the aluminium has no number after it, so that means that there is 1 aluminium. What that bracket with a 3 means that we've got OH times 3. And for now, we're just going to not worry about that times 3 and look just at the OH. For aluminium, we look up its mass. The mass of aluminium is 27. We multiply it by 1, that gives us 27. Now we're just going to look at the O and H. So treat that OH like it's a chemical formula. There is 1 oxygen and there's 1 hydrogen. And all I've done here is keep that times 3 in a column. Next step is to look up what the mass of oxygen and the mass of hydrogen is on page 7 of the data booklet, and that is 16 for oxygen and 1 for hydrogen. And now we've got our multiplications. We've got 16 times 1 times 3, which gives us 48. We've got 1 times 1 times 3, which gives us 3 for hydrogen. And when it comes to putting it all together to give us our gram formula mass, or our relative formula mass, it is 27 from aluminium, 48 from oxygen, plus 3 from hydrogen, which when added together gives us 78. One more example, ammonium oxide. So again, I'm going to break the compound up into the part that's in a bracket and the part that's not in a bracket. So I'm going to take the NH4 in a bracket with the 2 to the left-hand side and the oxygen on the right-hand side. Now the NH4 is in a bracket, so that means we're just going to multiply everything by 2 for that. And then for the oxygen, there's no number after it, which just means there's 1. So what we're going to focus on is treating the NH4 like we would any normal formula. We're going to break it into what atoms are present and how many there are. So there's no number after the N, so that means there's 1 N, and there's a 4 after the H, which means there is 4 of those. So we just write N times 1 and H times 4. And we keep that times 2 there. We don't worry about it until the very end. Now we need to look up the masses of an N and the mass of an H. So nitrogen has a mass of 14, hydrogen has a mass of 1. So it's going to be for nitrogen 14 times 1, and we've remembered we've got this times 2, so that becomes 28. For hydrogen it's 1 times 4. Then we have to remember we've got that times 2, which gives us 8. With oxygen, moving on to it, we've got oxygen times 1. We look up the mass of oxygen, it is 16. 16 times 1 gives us 16. And when it comes to adding together the gram formula mass, it's 28 from nitrogen, 8 from hydrogen, and 16 from oxygen, which gives us 52. So here are a few examples for you to work out the relative formula mass of. If you don't have access to a data booklet right now, just skip ahead. If you do have access to a data booklet, pause the video to give yourself time to answer these questions. So hopefully that is everyone who's paused the video has now restarted the video and you've got some answers. So what you should find is that for bromine Br2 it's 160, for calcium oxide 56, for water, which is H2O, 18, for carbon dioxide, CO2, should be 44, for P2O5 it should be 142, and for ammonium nitrate, which is NH4NO3, it is 80. Sometimes, and actually more commonly than relative formula mass, you'll be asked to work out the gram formula mass. Now the gram formula mass is the mass of one unit of chemical in grams. So all you need to do is exactly what you do to calculate the relative formula mass, but at the end you just put a G to show that the units are grams. So your gram formula mass, you do the calculation as you would normally do, but you just put the unit grams, which is the small letter g, after your number. What we're going to move on to next is percentage composition. And percentage composition just takes what you do with your gram formula mass or relative formula mass one step further. Our aim is to be able to calculate the percentage composition of an element inside a compound. And in terms of success criteria, we want to be able to calculate percentage composition for different elements using gram formula mass. The percentage composition of an element in a chemical formula can be calculated using the following equation. Percentage mass equals total mass of element divided by the gram formula mass of the compound multiplied by 100. So what you do is you calculate the relative formula mass or gram formula mass. You will then, from your question, you'll be asked about one element. What you do is you look at just that element in question and find out, after you've done the multiplication step, what the total mass coming from that element is. You divide that number by the relative formula mass or gram formula mass and multiply it by 100. Again, it sounds more complicated when described in words than when you see it done in action. So we've got sodium chloride here. What is the percentage composition of sodium in sodium chloride? Well, we go through our normal steps for working out the gram formula mass or formula mass. So number of atoms, mass of element, multiply and add. We have added them together and it's 58.5. Now we've been asked about sodium. So we're just going to look across to sodium. And the number we're looking for is the one under the word multiply. We also have got our relative formula mass or our gram formula mass, the same number, is 58.5. Our percentage composition is our total mass of sodium, which is that 23 under the word multiply. We divide that by the relative formula mass, or gram formula mass, which is 58.5, and we then multiply that by 100, which gives us 39.3%. When it comes to percentage composition, it's best to give your answer to one decimal place. So don't round it up to the nearest whole number, have one decimal place. So here's another example. We have got potassium phosphate, and we've been asked what is the percentage composition of oxygen. So this time we've got 3 elements. There are 3 potassiums, 1 phosphorus, and 4 oxygens. The masses of each element are 39 for potassium, 31 for phosphorus, and 16 for oxygen. We do our multiplication. We get 117 for potassium, 31 for phosphorus, and 64 for oxygen. When we add them together, we get 212. So we were asked about oxygen, and so the number we're going to use is the number underneath multiply, so we're going to use 64. And our relative formula mass is 212. So our calculation is 64 divided by 212 multiplied by 100, which gives us 30.2%. One way to check that your answers and that your method is correct is to try working out the percentage for every element in your compound. If your method is been done correctly, all the numbers for the percentages should add up to give you 100%. So that's if you've got time at the end of a test or an exercise or a homework to do this, try working it out for every element, add them together. If they add up to give you 100, that means you have done your percentage correctly. So finally, just some questions for you to try. Again, you will need access to the data booklet in order to do this. If you don't have access to the data booklet, well, thank you for watching this video. What we'll look at next time is an introduction to something that we would call the mole. But for this, if you do have time, have a go at these questions. So the first one is, what is the percentage composition of nitrogen in ammonium nitrate? Second one, what is the percentage composition of phosphorus in calcium phosphide? And the third one, the composition of potassium in potassium hydroxide. The extension question is, what are the NPK numbers for a fertilizer containing this? Now, NP and K numbers, those are the percentages of nitrogen, the percentage of phosphorus, and the percentage of potassium, just listed as a sequence of numbers. So if you've paused the video to have a go at those questions, the answers that you should get are 35% for nitrogen in ammonium nitrate. Remember, there are 2 nitrogen atoms in this, not just one. For the second one, 53.7%. For the third one, 71.4% potassium. And for the extension task, the NPK numbers for 8% nitrogen, 17.7% phosphorus, and 44.6% potassium. So that has been gram formula mass and percentage composition. Thank you for your attention.